If you are looking to make a manual verification of the quantity of the fasteners, which is the connection bolts, the anchor bolts and the screws, the angles, the trims, and the mastic, which is the closures and the sealants that are built out by the BOM program, then MBS provides a very useful and a powerful tool called the BOM check. This video will provide an insight into this tool. The BOM check report provides a breakdown of these 5 items that are used on each of the 5 surfaces, which is the 4 walls and the roof, thereby providing visibility to make the verification and understand how the software has arrived at the count for each of these 5 items. This is the model of the sample building when the IFC file that is generated is exported to Trimble Connect. And after running all the detailing cells, we are running the BOM check tool. And this report can be saved in 5 different files in the job folder for each of these tabs for record purpose. The reporting structure for each of the tabs is explained in the help. This is the help for the bolt tab. So the first column denotes the line number from the dtbolt.siz file, that is the source for this record. This is the description of the usage or the location. These are the number of bolts at this location, and these are 2 identical locations. This is the part name of the bolt that is used in this location, and the next columns are the properties of that bolt. Let us look at the first line item, which is end wall column to an end wall rafter connection, which we can see over here. This is a double clip connection, so there are 4 bolts on the flange, 2 on the web, making it 6 bolts at this location, which is the 6 over here. And these are the 2 identical locations. So there are totally 12 bolts for this connection on the wall 1, which is the left end wall. Similarly, this breakdown provides an insight of how at each location the number of bolts are calculated, and the summation of this on each of the walls and the roof is populated in the BOM, and the verification for the fasteners, that is the bolts, can be conducted. Over here are the bolts for the rigid frame connection. These are for the floor members, and here are the bolts for the crane. The anchor bolts for the columns of the frame, the end wall columns, the floor columns, and for the jambs are provided over here. These are the line numbers in the DTA bolt. These are the number of bolts at each of these locations. In summary, the summation of all the bolts on each of the 5 surfaces, that is the 4 walls and the roof, and the bolts on the rigid frame, floor members, crane, and the anchor bolts all are populated in the section 10 of the BOM under the fasteners, and this breakdown helps in understanding the bolt count. Next is the trim tab, and we access the help to understand its structure. The trim information is pulled from the database file dttrim. The first column is the trim marker that identifies a building location for the trim. Next column is the trim type, which could be a full-length standard piece or one of these options. The trim style is the next column, and the part name and the mark are the next two columns for the trim. The quantity of the trim pieces for the current item and the quantity of locations for the current item are the next two columns. The length of the item is in the length column, and there are the next three columns for the three identifiers. The color code, which is a two-character code, is in the color column, and the detail ID, which is in the detail column over here. And all this information for this marker is coming from the DT trim file. Let us take a look at the first entry, which is a base seal on the left end wall or the wall 1. The quantity that is billed out for this piece is 4 for this part name, which is FL72, and each piece is 122 inches long, which is 10 feet with a 2-inch lap. So 4 pieces are required for the wall length of 40 feet, and that is how we can verify the first line item. In this fashion, every line item can be verified, and the summation of the trims on each of the 4 walls and the roof is populated into the BOM. This breakdown helps us to understand and verify the total quantities that go into the BOM. The next three tabs are for the mastic, angle, and the screw, and follow the same structure as the trim table. The material from the DT mastic, DT angle, and the DT screw one are pulled into these three tabs respectively. The first column is for the marker from each of these database files, and the quantity for each marker is calculated and presented in the quantity column. The summation of all the items in this breakdown on each of the 5 surfaces should match the quantities in the BOM. In this way, the BOM check feature helps in the verification. The BOMCheck.exe is run from the C mbs util folder and requires no additional setup.